Hi everyone, I'm Adam. In this problem, what we want to do is match the differential equation dy over dx equal to sine of 2x with one of the slope fields labeled a through d. So how we do that is take a look at our differential equation and see if we can come up with some idea of what the slopes of the curves generated by the general solution of that differential equation would be. Well, how can we do that? Well, we take a look at what we have. Dy over dx equals to sine of 2x. And we kind of note that, say, at x equal to 0, what we would have is a slope dy over dx equal to sine of 2 times 0, or namely sine of 0, which is 0. So what that tells us is in one of the slope fields, for this particular differential equation, at x equals 0, we would be looking at slopes just as horizontal lines. So taking a look at our slope fields a through d, we see that a and b match that description. Namely, looking at x equals 0, we have slopes or horizontal lines, meaning slope 0. Now, how do we differentiate between the two? Well, if we take a look again between a and b, we notice that the slopes of all the curves to the left of 0 are negative, and the slopes of all the curves to the right of 0 are positive. And in B, we have slopes to the right and left being both positive and negative. Then we get some intuition about this. We see that our differential equation dy over dx is sine of 2x, and so the solution is going to involve a trig function which we know is periodic. Well, we'll be a little more analytic than that. So let's suppose take the x value 2 and see what slope we would get. If we get a slope that is negative in our differential equation, we know that b is going to be our answer. So taking a look at that, at x equals 2, our dy over dx is sine of, well, 2 times 2, or sine of 4. So what is sine of 4? Now, we don't care about the exact value, just the sign of it, whether it's positive or negative. So we can see this. If we quickly look at our unit circle, where we have 0, pi over 2, pi, which is approximately 3.14, and 3 pi over 2, which is approximately 4.71, and of course 2 pi. But what that tells us is sine of angle 4. 4 is between 4.71 and 3.14, meaning 4 radians is going to be in our third quadrant, where, again, we don't want the exact value, we just know that sine is negative. So sine of 4 is a negative value, means we have a negative slope at the value x equals 2, which matches the slope field of b. So our answer, as far as which slope field matches the differential equation, dy over dx equals sine of 2x. That's our slope field B. Thank you very much.